Hi, this is Jay Botello with WildPackets, and we're going to cover network forensics now for 10 gig networks. So we probably covered some of this about forensics when we were talking about timeline and storing the packets, but let me go ahead and cover this in a little more detail. So, what is forensics? Well, forensics is, I'd say, relatively new in the industry, 4 or 5 years of people talking about network recorders and that type of thing. It's really about capturing, storing, and analyzing network data, but it's not like TV forensics where it all happens after the fact. You have to have captured the packets. You have to employ it before something happens. What are some examples of things happening? Well, certainly nowadays, not the only way, but certainly a significant reason why network forensics is used is kind of as an insurance policy against zero-day attacks. IDS and IPS are pretty good. We work very well in conjunction with IDS and IPS, but there are things that still continually get through. And network statistics are saying it's happening kind of more and more out there, where there's more of these zero-day attacks. And once that happens, what do you do? Well, if you have a recording of all of the network traffic, you can dial back and start to do the analysis and look for what's unique and find those users who wouldn't typically have been on your network, or those protocols that wouldn't have typically been on your network, and sort of drill in and figure out the fingerprint of that attack, because you have all of the data. Without that, you can't do that. It's just an example of why network forensics is very important. So again, once the network traffic is transmitted, it's gone. So you have to have recorded it with a network recorder for network forensics for this to actually work well. So it serves a number of purposes. We can find the details of network events. We can use network forensics simply for network analysis techniques. There was a slowdown on the network 10 minutes ago. We want to know why. Perfectly good reason for using network forensics. The security example I gave, another good reason for using network forensics. One of the big things it does is it eliminates the need to have to reproduce a problem, whatever the problem was. And it doesn't even matter if we're talking about networks now or network analysis. Just as an engineer in general, most of us probably remember problems, where most of the time solving a problem is figuring out can I reproduce the problem? Can I get a reproducible case? Can I make this happen repeatably? Once I can do that, I can figure out the problem. But it's very difficult until you do that. Same thing is true with networks, right? Until I have seen the problem and can see it again, how do I go troubleshoot that problem? How do I know what's causing that problem? With network forensics, with network recording, you've already made the recording of the packets. Just dial back in time, figure out what went on.
Are you all doing any replaying or encoding of the streams? So an event happens, you've got the capture, and now you want to recreate it in a lab or a proof of concept or whatever.
Well, so we have all of the packets, so you can either analyze them with IonPeak, or if you did want to kind of replay them in time, right, we do have a utility that allows you to kind of replay the packets in the same timing that they came in at, if you chose to do that. We don't really use that for analysis so much, but we actually do use that for traffic generation a lot. Like if we want to, for testing and that kind of thing, if we have a unique situation, we can continue to play it back. Yeah.
And that tool's available? That's not an internal dev tool for you guys, right?
No, I think it's just in our system tools. It's called Peak Player.
Got it.
Yeah. So network forensics, basically capture, storage, analysis, that's what it requires, right? And I mentioned the security example, but it's as much concerned with enterprise networking as it is with lawful intercept or that type of an approach. Lawful intercept is just another ways that network recording is often used, right? Agencies that have a warrant can go in and record of networks. We've heard kind of far too much about this, right, with NSA and other things, and it happens all the time, and it can't happen. No one should ever consider that what's on their network is necessarily private. But the focus for forensics is really generally on enterprise networking, not just on that legal side of things. And it's always just based on a live IP capture. We're looking for traditional troubleshooting. So how does this work kind of in practice? So, in practice, back to that the example of zero-day attack, an attack might bypass the firewall. Okay, we've got a data recorder here, right here, that's going to record all that data. We don't even know the attack's going on yet. It's going to record all the data. The IDS, IPS, it may even see something that's odd. There's some flags that come up. You're not really sure what. Post-event analysis then allows you to go back to that appliance and replay what happened, see exactly what the source of that attack was. So, why do we need it? What are some of the applications for forensics? Well, as I mentioned, tuning the IDS systems, identifying the security breaches. Even things like logs, those are vulnerable, right? Now there's attacks where people can go in and change logs. So that may not be a reliable source of information. The network-based evidence might be the only evidence that's untampered with that you can really rely on to go back and figure out what happened in an attack. Of course, it is used for lawful intercept requests. Identifying rogue devices, even enforcing things like corporate compliance policies. So if there's been activity on the network that you don't really want, whether it's peer-to-peer, maybe even documents leaving, all of that is recorded on a network recorder. So you can go back and see any of that in time. And of course, improving network performance. So we do that with Timeline. Timeline is our network recorder. That's one of the boxes that I attached to in the last demo. It'll record at 12 gigabits per second. And then we do some level of statistics in real time that people can see. So it's rapid, intuitive forensics retrieval, which I also kind of showed you in that demo, right? Picked a slice in time. We got, the box went back, analyzed those packets while it was still being written to, and we were able to see the results of that analysis. That was the voice over IP that we looked at. It's really a natural extension of our product line, and that network recorder is a turnkey bundle. So it's kind of get everything in it that's needed for a user to be able to deal with that. We saw some of those kind of screenshots already. One of the other things that we can do once we go analyze a slice in time is we can also reconstruct traffic when needed. We have plugins that do this kind of thing, so we can go back and do things like reconstruct an email from somebody, even down to seeing whether or not they have attachments, etc. And very useful for enterprise customers as well as lawful intercept. We can do it with things like web pages as well. So, why forensics? Part of it is to validate what your other systems are telling you. It's actually not just with forensics, but it's something that we find that's unique as a use case, I think, with deep packet inspection in general, where people are often using deep packet inspection to go back and verify other systems on the network, verify an IDS, IPS, verify packet shaping, verify these other things that you've configured to work in a certain way for you, that sometimes maybe just because of some misinterpretation or misconfiguration that aren't behaving the way you expect them to do that. With forensics, you can generate alarms and alerts that you won't ever find in your logs. You invest time analyzing, not reproducing. Like I said, reproducing a problem is the most time-consuming part of a problem. You can immediately begin any investigation. You have the recording, dial back right then, isolate key events, and you can really understand the depth of penetration. You can really see all the way down to things like what type of protocols was somebody using, who was the perpetrator, how did they get in, what machines did they touch, how much traffic went back from that machine to that user, etc.